Perfect. Can you guys hear me okay in the back? I'd imagine yes. So thank you, Jari, for the tremendous presentation. And I think this is one of the most concrete examples of, the future trends of AI. What is it actually going to do to the basic infrastructure of our nations, to the coding, to the software, to ways things are being built on the digital side? Now we will dive a little bit deeper into the practical implications of AI. My name is Ville Hulkko. I'm one of the founders of Silo.AI, a private artificial intelligence laboratory operating here in Finland. And the purpose of us is to fancifully say that we democratize AI. What this means in practice is, prior to the foundation of Silo, I used to work in Silicon Valley on different kinds of AI projects for many years. And around this time, a group of Finns recognized a problem, an opportunity and a problem here in Finland at the same time, which was that Finland is, in fact, one of the global top repositories of world-class AI talent that absolutely no one has any access to. It's sitting in academies, it's writing research papers, but it's not bringing that knowledge to the use of our industries, to the government, to the infrastructure that we have. And thus, we wanted to create an environment for these people to contribute their skills to the good of the Finnish societies and for the European industries, and thus Silo.AI was born. Today, we are 35 people. Most of us are former or current researchers, PhDs, masters of machine learning, computer vision, natural language processing, and we solve difficult problems of clients by using these latest cutting-edge methods. But enough about that. The topic at hand is what executives should know about AI. Because when we look at the news, this is what we see. AI drives us to work. It reads bedtime stories to our kids, and every now and then it's been known to cure cancer. That's nice, but it doesn't really make for a fruitful base to make business-driven decisions. And thus, we'll need to ask ourselves the question, what is AI in a business-driven sense, and how do we approach it? Now, AI today is a bit of a buzzword, and the ironic thing about that is, once technology is new, it's AI. But once it's been embedded, let's say, into an iPhone, it's no longer artificial intelligence, it is facial recognition technology. So it's kind of a bit of a fleeting term. But in general, what AI is referred to is a self-learning system. Different derivatives of machine learning, meaning that a computer program programs itself to fill a specific goal without the explicit interference of a human being in altering the code. This is the essence of machine learning, and this essentially is what artificial intelligence is referred to when we speak about it in the industry. At Silo, what we do is we in Finland help organizations get onboarded with AI-driven operations in such a way that companies that do not have artificial intelligence can start implementing these kinds of solutions into their everyday operations. And I'd love to share some of the insights with you and some of the approaches that we generally speaking follow to make this happen. Because AI is fundamentally different from software business, even though they go very strongly hand in hand. What this means in practice is you cannot build or buy an AI that basically makes your company just better. But you have to handcraft an artificial intelligence system or a machine learning system to support a specific goal or a process within an organization. Meaning that you take a task, you figure out the business objective, you figure out the right question to ask from the machine learning system, then you figure out the data inside, what models to use, where it should be deployed, and so forth. And it seems my numbering is a little bit off by basic mathematics. But okay, this sounds very abstract. What does this mean in practice? Let's say that you are a company that is looking to improve the efficiency of your customer service operations through machine learning. And in order to do that, what you do is you implement a chatbot framework, a self-learning system. And in order to do that, you need to be able to ask the right questions and determine the business objective, which is to improve the efficiency of every single customer service representative within your organization. Now, how do you do that? First, you get the historical data to support this kind of a machine learning operation. And this kind of historical data can be any interaction between the company and the clients. It can be emails, chat conversations, cell phone conversations. You take all of that historical data and you convert it into a machine-readable form that you can feed to a self-learning system. After that, what you, for example, can do is figure out, using clustering algorithms, 10 most frequently asked questions. What people, generally speaking, ask from your company as they engage with you. As you figure out the 10 questions by scrambling through the historical data, you can then create customized automated answer templates to those questions and deploy it through not necessarily even a customer-facing chatbot interface, but an interface that discusses with the customer service representative. Therefore, what ends up happening is when a customer query comes in, an AI reads through the question, through the email, figures out, okay, this question sounds like it's relating to the opening hours of our stores. Then the AI crafts an example answer and it presents it to the human customer service representative. The human then reviews the answer. If the answer is correct, tremendous, it's sent forward and the case is solved. If it's wrong, the human labels it down, corrects the answer, and then the chain of customer service is never broken. But what we end up creating in this kind of a situation is what we call a feedback loop, a learning loop of AI. Meaning that with each customer interaction that comes in, a successful one reinforces the behavior of the AI. This went well. And a bad one, again, gives a bit of a different kind of a signal. This wasn't a good answer. Meaning that with each repetition, we improve the automation of our organization. Then, as we reach a performance level, we can start expanding on the capabilities, opening up new questions. But the first goal of this kind of an automation can be not to automate the customer service department fully and fire all the people. No. But to improve the efficiency of every single human working there by 10, 20%, gradually 30, 40, 50% as the machine improves. And this kind of an approach is fundamentally at the core of business-driven AI when you implement it into your everyday company processes. Another example of this kind of what we call a human-in-the-loop approach is visual quality inspection, right? Let's say that you are a steel factory or a factory that manufactures car hoods and chassis. In order to validate the quality of these products, you have a camera-based visual inspection system. A human sits in the booth, looks at a monitor. When there is a scratch or a dent or a hole at the hood of the car, it gets taken aside. Once you implement basic machine learning to the loop, what ends up happening in the process as well is when a flaw is identified, a picture is taken, it gets fed to a self-learning system, and thus, with every flaw passing through the system, the automation level improves. Creating these processes is what we refer to as annotation. Like Jari's tremendous presentation before on supervised learning, annotations are what we use to create data sets that feed an AI. And they can be as fundamental as pictures of holes in a steel plate. But at the core of this is to sit down and ask ourselves the question, where do we find the processes within our organization's operations? Where a human is doing routine-based work, how do we teach some of that routine-based work to a computer so that the computer can in return make that human more efficient? This is what we call a human-in-the-loop approach. And at the core of this, as we discuss about the future trends, is in user experience design, how do we create user interfaces and software tools that do this kind of a teaching process in the least intrusive way possible, so that when the human teaches the machine, it doesn't take the time off my day, but it happens intuitively alongside of the work that I do. And at the same time, we need to ask ourselves the question, to us, what is data? Because when I now say the word data, all of our minds are filled with Excel sheets and JSON files and green numbers raining down on a black background. But from a machine learning perspective, what also is data is the way we do things currently. What are the processes that we follow and why? What are some of the measurable outcomes of the processes that we do? Because unless we can very clearly define what the measurable target of these processes are, for example, of a visual quality control system, there isn't really a way for us to know if our machine learning systems are doing a good work, and thus there isn't really a good way to teach them. But the last, and when we talk about today's machine learning systems within everyday processes, perhaps the most important question is, how do we quantify the silent knowledge of the engineer who's been repairing airplane engines for the last 20 years? How do we tap into the silent knowledge and all of the expert information that person has of the process, quantify it, and use it to improve some of the systems that we build? And in order to do this, for example, again in the heavy industry kind of a fashion, one of the most common topics of not bringing a human in the loop but using very large-scale data modeling as part of it is, of course, predictive maintenance. A part where it's very difficult to bring a human in the loop and you have to rely on the heavy scale, big muscle calculation power of the artificial intelligence is, of course, to predict and model all the complex causalities within major engines. So let's say that you have a paper engine and you want a failure within a paper engine, a minute's downtime can cost tens or hundreds of thousands of euros. But in order to predict that, you can't just take one thing into consideration. You have to be able to understand the network. And that is a task too large for a human. So in this case, an unsupervised learning system where you necessarily don't bring a human in the loop will thrive. Another human-driven, maybe heavy industry or traditional industry kind of a use case where AI can be used, for example, through computer vision is, when we discuss about computer vision, what we see is beautiful people with point cloud images upon their faces and people opening their iPhones using their own beautiful selves. This is not a colonoscopy. This is the sewers of Stockholm. And basically, today, the sewers of Stockholm are being infused with countless and countless and countless of cameras. These cameras film the contents of the sewers all the time and aim to, the SD cards are then being extracted and people review the results and try to identify upcoming stockages or objects that don't belong there. Oh, it's a bit of a shitty job, if you will. But when we implement a machine learning loop into this, what we can start doing is annotating, bringing the human into loop to recognize some of those blockages within sewers and start doing it automatically so that those poor students who now have to look through this material can use their time in a bit of a better way. A very rudimentary process, but again, a way where human and machine working together creates efficiency through everyday processes. And of course, a question that is often asked in machine learning when we talk about RPA, for example, is what is the difference between an artificial intelligence system and an RPA system? And really the short answer is two sides of the same coin. Because when we build automation, what we end up doing is we bring a software to create an initial tremendous improvement in efficiency because we can again offload some of the human's tasks to a machine. When we bring machine learning to the loop, we take that initial level and we create the learning loop process where with every repetition, the efficiency of that system keeps gradually improving. So generally speaking, when you discuss about RPA, when you discuss about machine learning, they're not two different things. They do not compete. They complement each other. And of course, I don't need to tell you after Jari's presentation that Devops and the way we structure code is going to be experiencing quite the interesting days ahead. But taking a step back on what is feasible today, for example, in some of the first Devops automations in the most basic and rudimentary way, is already beginning to learn the structures of individual companies and their code. How do individuals write code? How is it structured, processed, stored, everything like this? And once you build that, and once you build the machine learning driven understanding about a company's processes, you can begin tracking deviations. What if the code gets significantly shorter or the structure changes? This is a sign of an anomaly and potential risk of a bug, for example. So using very simple solutions to tackle some of the first problems within the software creation process, but if you can use that to make your software deployment even 5% more efficient on the first day, that is worth a lot of money. Also, what ends up happening when you take the scale one level up is once you're not tracking or tracking the code not just at the micro level, but also at the workflow level. How does the organization process itself? You can begin also tracking deviations in ticket pileups, in bottlenecks that are being built or structured within the code-driven processes of a company or code deployment. And also if knowledge silos begin to form within the way that you do your business today. But maybe to recap, the two main goals of machine learning today, in today's business, not in the way artificial general intelligence will take over the world in a few years, but how we implement business today to bring value is two things. Make our humans, our employees, our operations more efficient. And second, to bring in business that was not possible before due to scale limits. Examples of these are, for example, through computer vision and natural language processing. As we today are able to quantify data in mass that before was only reserved to the processing of us humans, for example, news articles, videos. 82% of global data transfer in 2021 will be video, according to Cisco. So as we're using computer vision and natural language processing to track this, this will open up very interesting new business venues. But for the everyday processes that we automate, stick with this one. This is something I have to mention, at the risk of being a little bit political. But for the first time in the way software and intelligence systems are being built in the world, options actually make a difference. What this means is, I'll explain this very quickly through a short story of a personal experience of mine. In my previous career, we were building a video artificial intelligence platform in California that we sold to various movie studios, broadcasters, news agencies, and so forth. And once we, as a 10-person group from Finland, went to speak to Warner Brothers and so forth, what we actually realized is that they welcomed us with open arms. And this, of course, baffled me, but I later realized why, which is that for these companies, where you buy your learning solutions from is not a trivial question. Let's say that Universal Studios would use Google's self-learning services. What you end up basically doing is Google has YouTube. They have all the publishing platforms and they want to get into entertainment. You end up feeding the beast that kills you. In Finland, again, like in Jari's presentation, what we saw was the Google Assistant. A completely new paradigm of how the world is being controlled in user interfaces in the future. Not through this, but through this. And in order to do that, you need a very simple algorithm on the top, which is a speech-to-text converter. Something that understands how we speak and converts that into machine-readable form. This change will come, and we will begin building our next infrastructure of speech-driven services to, Marja Mummo from Hyvinkää, who has to use her banking services, not through this and learning the, online systems, but just saying that pay my bills. If we buy those solutions from the black boxes in Silicon Valley, what we end up doing is creating an environment and an ecosystem that is Silicon Valley dependent, because we don't know how that data feeds back to us. But what we do know is that with every query, like with the human in the loop, the systems get a little bit better. And this is why it makes a difference where we actually choose to buy the algorithms from. So not just as a greedy, as an entrepreneurial service provider, do I say this? But this is actually something that we fundamentally very strongly believe is important for all of us to recognize. I'll maybe finish with some tremendously good points from Harvard Business Review, published at the end of last year, that works as maybe a bit of a mindset when exploring about AI. And the first one is, don't believe the hype. When you read the news, when you listen to, us, what it seems like is everyone is already using AI, and if you're not doing it, you're late and your business is going to die. Don't worry, that's not the case. Everyone is talking about it, very few people are actually doing it in important scale. So it's not too late, but now it's the time to start exploring. And at the same time, believe the hype, because the companies that did start exploring, like we heard in the past, did receive measurable improvements in their everyday operations. Take it step by step, so don't eat the whole elephant at once, but start from the processes where it actually makes sense. You don't have to go at it alone. In this presentation, what we discussed is the importance of finding those right use cases for the first machine learning solutions, and finding those isn't always easy. That's why the industry is filled with people, for example, with Ethicode, that basically handle your basic, but basically the future of how data is being processed within your organizations. Consult with those people. Find the best business use cases and use that to build smart systems. Take a portfolio approach. Again, revolving around the same point. Start small. Start with something that you can measure, but don't stop there. Because what the portfolio approach also means is, on the medium and the long term, you have to think about the way you store your data today. What do you collect? What do you lack? What are your business's bottlenecks in your information technology? And how would you solve those in the future to be able to onboard those self-learning machines into, for example, the code workflow? And of course, digital capabilities come before AI. AI eats data, and if the data isn't there, or it's poor in quality, I don't know what to tell you. This is why take a very rudimentary approach, take it small, take it step by step. But lastly, be bold. The companies that go forward with this, the companies that challenge, are the companies who take the positions of market leaders in the future. Because I referred to Jari's tremendous example in the end about Google. If Google openly says that the future means that the people who do our core business are starting to become obsolete, this is a sign of a fundamental shift. But that shift isn't here today. The shift starts in small steps. So find those small steps and build them. All right, thank you. Any questions about this, or AI, or machine learning, or the human in the loop, or any of the fancy buzzwords that have been thrown around today? Yes?
It would be nice if you could share some case examples and perhaps elaborate a bit on how does Finland stand on the sort of AI landscape from your point of view?
Sure. So maybe if I start from the end, Finland's stance is certainly very interesting because what many of us don't know is we actually top some of the top global academics and research organizations here. Matti Pietikäinen, who's the head of computer vision department in Oulu, has more citations on his research than Fei-Fei Li, who is basically the mother of computer vision in Stanford and now works as a head of AI research on Google. And no one knows about this. And some of the prime case examples, for example, in the everyday process, like in financial sector, let's say that investment bankers who make investment decisions today have to read through documents, what we call prospectuses, 800 pages of PDF text this small in order to find the relevant information, whether or not this investment makes sense or if there's risk involved. Very mechanical, very repetitive. So what we, for example, built there is a human-in-the-loop system that starts off by learning first what are some of the risk sentences within those documents that signal an investment risk, finds it and auto-extracts it for those investment bankers. So now instead of reading through 800 pages of text per investment, what they get is a summarization. And in those summarization, the AI suggests, hey, I think this and this sentences indicate an investment risk. What do you think? And then the banker says, yes, yes, no, yes. And again, we built a human-in-the-loop system which keeps improving with every investment decision the bank makes. Any other questions? Yes.
So this goes a little bit out of this scope, but anyway, you are in the front line of the AI. You have seen what would be done with the data mining. And do you have Google accounts? How
We
you
do.
secure yourself because you are in the front line and you know that you will give the food to the beast?
We do. Maybe in this case, I'll sort of have to take a bit of the hypocrite stance, because at the same time, what we'll need to recognize as business decision makers is that utility and convenience comes first, right? And this is the fundamental thing of AI as well, is that we'll need to make decisions that make our organizations more efficient. And in this case, using Google G Suite in our organization is one of those decisions.